Page IN13, lesson IN3 is on probabilities of independent events. And the question is, how can a model help in finding the probability of two independent events? So, if you look at this, solve and discuss it. Talia is playing a game in which she must choose option 1 or option 2 and then spin the game wheel, flip the coin, and roll the number cube labeled 1 through 6. For her to win a prize, all of the conditions listed under the chosen option must occur. Which option should Talia choose and explain? So for option 1, for her to win, she would have to get the game wheel to land on an S, the coin to land on tails, and an even number to be rolled. For option 2, the game wheel would have to land on a Z, a coin could land on either side, and she has to roll the number 3. So what we're trying to look at is which one is going to give her the better chance of winning here. So we could do a tree diagram of looking at all the different possibilities. Let's just maybe look at what the different ways are that we could win here. So for option 1, one way we could win would be S, tails, and a 2. Another option would be S, tails, and a 4. Another option would be S, tails, and a 6. Those are the only 3 different ways that we could win for option 1. If we look at option 2, first of all, the game wheel has to land on a Z. The coin can land on either side, so one option would be the coin could land on heads. And then we have to roll the number 3. So Z heads 3 would be one way of winning. The coin could land on either side, so another option would be Z tails and 3. And those are the only 2 ways that we could win. So if you look at it, option 1 has 3 ways we can win. Option 2 only has 2 ways that we can win. So option 1 is going to give us a little bit better chance of winning. Neither one is super probable of happening, but a little bit better chance with option 1. And if we wanted to figure out like what the actual probability is, we could do a tree diagram, or there's another way we'll talk about on how we can figure out the probability and figure out like how many options, which I guess we already kind of talked about, so I'll just go ahead and mention it here. So on the spinner, I think it looks like more, but there's actually 15 things on the spinner. The coin, we have 2 options. The number cube, we have 6 options. And then kind of like we did in the last section, if we would multiply those together, that would tell us how many different possibilities there are. So 15 times 2 is 30, and then 30 times 6 is 180. So there's 180 different options, 180 different combinations, we could say. So with option 1, what we will be getting into is option 1. There's like a 3 out of 180 or a 1/60th chance of us winning. Option 2, there's a 2 out of 180 or a 1 out of 90 chance of winning. So not real great odds, but way better than the lottery. Example 1, we're trying to find the probability of independent events. First of all, independent events, if you look over here, independent events are where one event doesn't affect the other event. So like if I'm flipping a coin and I'm rolling a number cube, those are independent events because how I'm flipping the coin or what I'm getting on the coin isn't going to affect what I get on the number cube. So on example 1, Sadie has 1 ticket left at the school fair and she has not yet won a prize. What is the probability of Sadie winning a prize with flip and spin? So what is the probability? When they're asking for the probability of something, we're going to write kind of as a fraction, like we talked about at the end of that last problem, of what our chances are of winning in this case. So for flip and spin, you have to flip a head and spin blue. So one way of doing it, what the book did first, is they made a table of all the different options, and they said altogether there's 8 different options, and the way for us to win is if we get heads and blue. So if you look at your chart, heads and blue, that's 1 out of the 8 different options. So the chance of us getting heads and blue, the chance of us winning, is 1/8 or 12.5%. We're mainly going to just keep these as fractions, but if you wanted to find the percentage chance of winning, you could just divide that out and then move your decimal 2 places to the right. So that's one option, using a table. The other option is just to think about your probabilities. So when you're flipping a coin, there's 2 possible outcomes, 1 favorable outcome. So the probability of heads would be 1/2. And then when we do the spinner has 4 sections, only one of them is blue. So the chance of us, or the probability of us spinning blue, is 1 out of 4, or 1/4. So when we have independent events, what we can do to find the probability of both things happening, or all of the things happening, is we're just going to multiply those probabilities together. So if we take 1/2 times 1/4, just multiply straight across, you will get 1/8. So it's kind of 2 different options. You can do a table, especially if there's a lot of things, then it might be easier for you, quicker for you, just to multiply their probabilities together. But technically you have either option available when you're doing these problems. The designer of Flip and Spin creates a new game using a 5-section spinner as shown. How does the new spinner change the probability of winning a prize? Okay, so they're really shaking things up here and changing their spinner. So if you think about this, we want to get now still the same thing. We want to find our probability of getting heads and blue. So the chance of us flipping a coin and getting heads is 1/2. And then on the spinner, the chance of getting blue would be 1 out of 5. And then if we just multiply, that would tell us the chance of getting heads and blue. So multiplying, that would be a 1 out of 10 chance. Looking at the blanks that the book has, just in case you're curious here, these are basically going to be filled in with what we have so far. 1/2 times 1/5 equals 1/10. And then it says or. The or part is for the percentage. So percentage actually, remember percent's a number out of 100. So this one, easy enough, we could just multiply by 10. That would be 10 out of 100, which means 10%. So then the next part just says it is blank likely that a player will win a prize when using the 5-section spinner than the 4-section spinner. So is this more likely or less likely? And the answer is less likely. Here we have a 1 out of 10 chance. If you remember before, we used to have a 1 out of 8 chance on their old game. So they decreased our chances of winning here by adding another color. Example 2, what is the probability a coin flipped 3 times will land tails up all 3 times? So what the book did, they did a tree diagram, kind of like we did with the kids the other day, chances of boys or girls. And if you look at these, to get all 3 tails, there's only one route. This is the only route that gives us all 3 tails. So we could look at that, all 3 tails, one option out of, if you look, there's a total of, including that one, there's a total of 8 options. So we have a 1 out of 8 chance of getting all 3 tails. Another way we could do that, instead of drawing out a tree diagram, is we could think about the probabilities. So if we just do T for tails, the probability of T, probability of tails is 1/2, probability of tails is 1/2, probability of tails is 1/2. You multiply, and that's where we can get 1/8 as well. So again, that's going to be probably a quicker route for us. But if it's easier for you to visualize and think about what's happening by doing a tree diagram or a table, then do it that way. So if you look at the try it, it says, is it more likely a coin flipped 3 times will land heads up exactly once, or will land heads up exactly twice? To figure this one out, we probably really want to go with either the tree diagram or a table. This is a little bit more complicated than just saying, I want this one thing to happen. So heads up exactly once. So if we look at this, they already did this tree diagram for us, so we might as well use it. So to get heads just once, we could have heads, tails, 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 heads, tails, or tails, tails, heads. So to get heads exactly once, that's 3 options out of a total of 8. And then heads up exactly twice. So for this one option, heads exactly twice would be heads, heads, tails. Another option would be heads, tails, heads. Another option would be tails, heads, heads. So if you look at that, once again, we have 3 out of 8 chance of that happening. It says, is it more likely that it will be heads exactly once or heads exactly twice? And so the answer is neither. We could say the probability of both is 3/8, or the probability of either one is 3/8. Example 3, what is the probability a coin tossed 3 times will not land tails up all 3 times? So this is dealing with what's called complementary events. So complementary events are events, whose probability adds up to 100% or adds up to 1. An easy example of this would be if you think about the weather. So for example, we look at the chance of rain, and they say there's a 20% chance of rain. What that means then, the complement of that is the chance of it not raining would be 80%. So we could say there's an 80% chance of it not raining, would be a different way of looking at it. Another way we could look at complementary events, flipping a coin, heads or tails. Heads is 50%, tails is 50%. And I said 100% or 1. The reason is, if you think about 50%, that's a 1/2, we could say otherwise. tails is 1/2. If you do a half plus a half equals 1. That's a different way of looking at it with fractions rather than percents. So back to example 3, the probability a coin tossed 3 times will not land tails up all 3 times. What we can do is think about, first of all, what's the probability that we would get tails all 3 times? Well, 1/2 times 1/2 times 1/2 is 1/8. So we have a 1/8 chance of getting all 3 tails. So chance of not getting all 3 tails would be the other piece of that. 1/8 chance of that happening means we have a 7/8 chance of it not happening. 1/8 plus 7/8 adds up to 8/8 or 1. Okay, again, those are complementary events. So if you look at the try it, Casey will toss 2 coins. What is the probability of the 2 coins landing heads up? What is the probability of the 2 coins not landing heads up? So probability of both heads, chance of heads is a half. So a half times a half is a fourth. So a fourth of a chance of getting both heads up, and the probability of them not both heads up would be 3/4. 1/4 plus 3/4 equals 4/4 or 1. And again, quickly we could draw this out, the different options. This is really not a big deal at all. Otherwise, if you just want to, make a table or something, and then you could say chance of both heads is 1 out of 4, and then the rest of them are not, and that's a 3 out of 4.